Can you hear me? 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 Can Testing. Hello? Okay, third time's a charm. Welcome to the OWASP Austin chapter meeting for May, last day of May. And how many here are at this meeting for the first time? Great, welcome. Okay, so I'm going to go through some slides and then we'll introduce our presenter. Today, sponsors for the food is LastCon, and we'll talk a little bit more about that. And then National Instruments, thanks them for providing the venue here. Here you will see we have our chapter leadership. Not sure how easy that is. You can see from there. But we have myself, I'm the chapter leader, Kate, the speaker and special event coordinator. We have Logan, who's the co-conference coordinator for our LastCon, and Matt Pardo, our education coordinator. Kyle Smith, David Hughes, and Josh Sokol are our advisory board members. And if you have any questions about our chapter, just talk to any one of us. For CPEs, you're eligible to get earn an hour of CPE towards your certifications. What I've done so far is just to have people just let me know, contact me and let me know if you want to have a certificate sent to you, as opposed to just trying to print a whole bunch of them or email a whole bunch of them. So just contact me after the meeting if you want. We have a study group that we do that's also here at National Instruments, and this Thursday we're starting a book that's basic security testing with Kali Linux, and Matt Pardo is our education coordinator. He's going to be leading that. If you have any questions on that, you can talk to Matt. And we should be posting on the Ning site. We'll get some more information up there on where to buy the book and such. Some other chapter information, memberships for individuals. There's 3 different types that you can purchase. Corporate memberships, if you have a company that you would have several people that would want to be a member, it might be worthwhile to do that. And then they also offer a student membership. So you can find out more at the austin.owasp.org. And also just for showing your support, volunteers, if you would like to volunteer for help out with anything, you could contact us. Also on Amazon, there's the smile.amazon.com where you use that to, when you do purchases, a portion of that goes towards OWASP. Some upcoming chapter events. The Austin Security Professionals Happy Hour is going to be, I guess this is next Thursday, June 9th at Sherlock's. And I'll be sending out an email to announce that here real soon. If you're not already on the OWASP Austin mailing list, I would suggest you go ahead and sign up for that so that you can get the emails to let you know some for upcoming events. And also for some training, Matt is starting to look into something, I guess more details to come. I don't know if we have that really set to where we can talk much about it yet. Very large firm. I don't know if I want to say this. Very, he is an expert at it. Okay. Thank you, Matt. And as far as conferences, we have our LastCon 2016 coming up in November, so save the date. And actually, Logan is going to speak a little bit about that.
Hello, everyone. I think this is the first time I'm up here standing in front of you, so it's nice to meet everyone. LastCon is coming up here in sooner than we would like, I think. There's a lot of stuff going on. The call for papers is live, so if you go to cfp.lastcon.org, you can submit a talk. So I encourage you all to go and do that. Hopefully, most of you on the mailing list might have got an email from us announcing this. So we just got a new version of the website launched yesterday. We, staying productive over the holiday weekend. So check out the website, for more details. I think there's a link to the CFP in the nav bar as well. So yeah, just keep it in mind at this point. Thank you for your time.
Yes, definitely. So bye early. Some other upcoming local events, just peruse some of the websites to get these dates, and hopefully they're correct. And is anybody here would like to have any other announcements of any events going on? Okay. And just more chapter information, again, you can go to Austin. Yes, I'm sorry.
ISSA's sponsor your training on the 16th. It's the author of the Red Team Handbook that is this RTFM. He will be doing a one-day training. He's also speaking at the ISSA meeting.
Okay, thank you. Yeah.
DEFCON 512 and ATX 2600 meets this Friday evening, 7 p.m. at Chicon Collective.
Thank you. Anybody else? And now, Kate's up. Oh. Yes, if anybody has any jobs openings that they would like to announce. Okay, so here's Kate.
Hello, it's with great pleasure that I introduce Dan Cornell. I've been asked to introduce him by his colleagues who know that he is too much of a nice guy to brag about himself, so I'm going to do it. Dan is a globally recognized application security expert holding over 15 years experience architecting, developing, and securing web-based software systems. As CTO and principal at Denham Group, he leads the technology team to help Fortune 500 companies and government organizations integrate security throughout the development process. Dan is an active member of the development community, as we see, and a sought-after speaker at a number of international conferences, including RSA, OWASP ZAP, OWASP AppSec USA, and EU. Black Hat Arsenal, and TEDx.
Thank you.
Welcome, Dan.
Good to see some of my denim group colleagues here today. For some of you might recall, we have they must be here for the free food, not for me, because the last time I was supposed to have lunch with a bunch of them. We have an award called the Chuck Norris Award that we give out monthly to a team, and part of that is that you get a team lunch. So one of the teams, primarily based up here, won the award. I drove up to pay for the lunch. Set up in our Austin office and was working away in a conference room. And at some point, I kind of looked up and said, I feel like we should have been at lunch by now. So I poked my head out and asked the admin. I was like, hey, where'd everybody go? And they're like, oh, they all went to lunch. I was like, they do realize I was supposed to pay for that lunch, don't they? But so you see the level of respect I receive inside of my organization. So thank you, Kate, for the kind introduction. Sometimes I have to go outside to fluff up my ego. So. All right. So today, let's see when this works here. What I want to talk about is we call it source-assisted pen testing, or using source code to assist in web application penetration tests. And I want to walk through some simple use cases of some technology that we've built and released in the open source. It's technology we developed along with or under the funding support of the U.S. Department of Homeland Security that we've open sourced for anybody to use and contribute to. And again, love to answer questions about. We've released it as a plugin for ZAP. We've also got a plugin, comparable plugin for Burp, and I think AppScan. As well as a command line version of the stuff. So I'd love to hear people's feedback, as well as thoughts people have on additional things that you could do using source code to help with pen testing. So agenda-wise, talk a little bit about background, my background, which will be short. Look at the arguments for using source code to assist in these types of activities. Provide some background on this. We call it the hybrid analysis mapping, or HAM technology. Go through the installation instructions for the plugin for ZAP, and then talk through three different topics that are three different areas where we see the use of source code as being potentially beneficial: attack surface enumeration, backdoor identification, and testing for configuration settings. And we'll have some time for questions at the end, but if you have questions along the way, please feel free to raise your hand and ask. Love to answer questions. And I recently gave this talk in Boston, and they had really good questions. So let's see if you guys can have better questions than the people in Boston. That's a little friendly competition. And how is this mirroring? Okay. Yeah, read ahead and be like, come on, Dan. Like, we got it. We got it. Yeah, even better. I don't even have a script. And if it's working like this, then the fact that I can just make the slide thing bigger, the transitions will probably be too long anyway, just because I've got to hop out for demos and stuff. Okay. Yeah. You want to leave it like that? Yeah, that's fine. Make these bigger. There we go. Now you can read ahead, but only if you have really good eyesight. Alrighty. Okay, good. That's a picture of me on a slide. I guess the important piece of information on this slide is that I'm a developer by background, so a software developer originally out of some early server-side Java stuff in the early 2000s, did some early .NET, ASP.NET stuff. But really, I've spent the majority of my career, the last 10 or 15 years of my career, looking at how software developers impact the security of the organizations that deploy and field their code. And so I have a different background than certain people in security in that I'm a developer that has come into security as opposed to being someone from a more traditional systems administration or network pen testing background, now looking at applications and web apps, mobile apps, and things of that nature. So that kind of colors some of the I characterize things. why use source code when you're looking at doing penetration testing? And first of all, just for the pedantic people or the pedants in the audience, this is not necessarily we're not necessarily talking about penetration tests. This is more of a source-assisted web application assessment, maybe the more correct way to say it. There's a great Futurama quote. They say, "You are technically correct," which is the best kind of correct. I actually was in the office on Friday, and someone was drawing on the whiteboard talking about a reverse proxy setup, and they said, "Well, so when this gets hit, what it does is it bounces around. He's writing on the whiteboard, HTTP, 10.2.235, colon, 88.755," and I was like, "You do realize that's not a valid port number?" Everybody in the office stops, and I was like, I'm sorry, that's the most pedantic thing I've ever said, and I hope it is the most pedantic thing I ever say in my entire life. But it is worth looking at terminology. So, this is what we're really talking about is source-assisted web application assessments. That title is not as catchy as web app pen testing, so we find ourselves here today. And I think with some folks that we've talked to about this, we get the perspective of what's the matter? Aren't your folks smart enough, or why do you need the crutch of source code in order to do this? In order to do this testing? Or a lot of times when we're talking to organizations about doing testing for mobile applications, when you look at the mobile client, they're like, well, why would we give you the source code? You should be able to reverse engineer this source code. And my answer is yes. We do have people that can figure out, reverse engineer the source code, pull the machine code back with Android. You can basically script it, all the way back to the Java. But it comes out to a question of goals. Is your goal with the engagement, of a penetration test, is your goal to make a point to say, given no information, here's where a knowledgeable attacker is able to get themselves, and that is a valid goal in a number of situations. What we find more frequently, though, with organizations, especially when a lot of folks that are asking for penetration tests, they're actually looking more for an assessment, because their goal is to say, I have a budget of X number of dollars or Y number of hours or whatever the currency is. There's some limited factor, and the goal of that organization is to figure out, how can I get the greatest level of security insight into the state of this system given this budget? And so in a situation like that, if you have source code available, yes, you want to use source code in order to further this test. If you assume in the real world that and again, depending on the threats that your application is facing, for certain things you need to assume that attackers have nearly infinite or a tremendous amount of resources they can throw at this. And so looking at it, is it a question of, how much guesswork do you want the testing team to have to go through? Do you want them spending time in that limited budget in order to go through the process of, we'll download the binary, turn it on with the debugger, wait for the encryption to be pulled off, dump the memory. Again, that's all stuff that can be done. Or would you rather have that time spent, given the source code, getting additional security insight? And so that's one thing that I think is worth looking into or understanding. If you're looking at the benefits of using source code, there are things that are easier to test in a dynamic way. And in a lot of cases, there are things that are easier to test in a static way. And so if you have a limited budget and you're trying to maximize the level of security insight you get for the expenditure of that budget, providing access to source code only makes sense, because that's you've got a question, hey, I think this is how this is behaving. Well, cool. Let me check the source code and I can see how it actually behaves. And so what we're going to look at here are some examples of how you can use source code, and more specifically, how you can use some automation around analysis of the source code to help inform the activities that a dynamic tester or a pen tester would take in order to, again, gain greater security insight into the system that you're looking at. So I'll provide a little bit of background on this technology we've developed. Again, this is stuff that was developed under a contract, or a series of contracts with the U.S. Department of Homeland Security, called the SBIR, or Small Business Innovation Research Program. If anybody has questions about SBIR, I'd love to talk about that offline. That's been a really interesting program to participate in. Different federal agencies use it in order to encourage the development of technologies that they think would be useful. And so I think that our use of that program, I think, has been really interesting. And our goal with building this technology was to figure out, can we merge the results of static testing with dynamic testing. Can I take a set of results with a Fortify, for example, and stitch it together with a dynamic app scan? So just a little bit of background on the SBIR program. We're currently finishing up phase 2 of this DHS, S&T's SBIR, which, because it's a government program, they love the acronyms. But DHS is Department of Homeland Security. S&T is their Directorate of Science and Technology, and the SBIR, again, is the Small Business Innovation Research, again, geared toward developing new tech for federal customers. We call the technology hybrid analysis mapping, and we include it with the community edition of our ThreadFix application vulnerability management platform. And we've also plugged it into a couple of different components. And so this is all available from the GitHub site. If you have problems getting any of the stuff that I talk about here today, just shoot me an email or track me down on Twitter. We're kind of transitioning the way that we're hosting that stuff on GitHub. And so it's a little bit of it can be a little bit hard to track down parts of this. So if you have any questions, just shoot me an email. If enough people shoot me emails, then I will find a way to make it easy, because I'll be tired of answering emails. So I think that's the market forces in action. And so our original goal with this was to figure out how can we correlate and merge results from static testing and dynamic testing. And then from that, we've found that we can do some other really interesting stuff with the technology. Again, original scope was, can we take the results specifically from Fortify SCA and merge those together with the results from an app scan, an app scan standard dynamic scan of an application. And that's something where we just saw a lot of organizations had these two technologies deployed. We're dealing with an overwhelming set of results. And so the problem statement that we had was, can we find a way to dedupe or merge these, to correlate these together to help with the data management problem that organizations had associated with their scanning program. The way that we approach the problem, it doesn't really matter what the source static results or the source dynamic results are for, which is great. But again, that was kind of the original scope that we had. So who here, presumably everybody is here, everybody here is familiar with, if you're not, feel free to stop me, but who here is familiar with dynamic web application scanning, or DAS in Gartner parlance, okay? Where you look at a web application, and the typical approach is to spider it much like Google would, to say, well, here's the front page, let me see all the HTML and the links to other pages, and maybe I'll look at the JavaScript and figure out like what other pages there are, if there's any forms to submit, and then I'm going to go to each of those pages that are referenced, similarly crawl them, so you spider the site much like Google would or another search engine. Typically a good dynamic scan is going to have some sort of authentication recording, so that you don't just see the pages that unauthenticated users can see. You also will have access to pages that are behind a login or some other authentication mechanism. Also some sort of session detection to let you know, like, oops, I accidentally crawled the logout link, and now I can't see a lot of stuff. But you basically lay out, here's the entire attack surface of the application by discovering it, by that spidering discovery process. Then after you do that, you fuzz the application. So you say, well, here's the pages that accept get parameters, here's the pages that accept post parameters, here's the ones that accept, here are the cookies that get set. I'm going to cycle through a set of different values for those, watch the request and response patterns, and from that determine if there is evidence of some sort of a vulnerability. So I'm going to send in a SQL control character, get back a page with a JDBC error message. Oh, okay, well, that looks like a SQL injection vulnerability because I caused some sort of a SQL error when I sent in this thing. And for our purposes, what we think a finding looks like, or a unique vulnerability to us from a dynamic standpoint, looks like a combination of the CWE, MITRE's CWE, which is the common weakness enumeration. It's basically a tree-like list of all the classes of problems that an application can have. Everybody familiar with MITRE's CWE? The worst vulnerability taxonomy available except for all the others. It's like the democracy, right? But it's the vulnerability type, the relative URL in the application, and for certain classes of vulnerabilities, like SQL injection, like cross-site scripting, it's also the injection point that goes along with that. So we have a reflected cross-site scripting at login.jsp for the username parameter. It would be an example of a unique vulnerability from our purposes. Everybody here also familiar with static testing? You look at the binary or the source code, you look at the application at rest, build a set of data structures like an abstract syntax tree, and then perform different analysis. You either do data flow analysis, tracking taints, you can do control flow analysis, semantic analysis, So here we see that we've got a get parameter call. We know that that feeds in potentially malicious or potentially tainted data. That then taints the username string. That username string gets appended to some static text and assigned to that SQL variable, which is also now tainted. We see that we've got a sensitive column. We pass a tainted variable to that. So from that, we say, oh, well, that's a pattern where we're passing in malicious data. It's bouncing its way through the application, being sent to a sensitive function. That looks like the type of pattern associated with a SQL injection vulnerability. And so for our unique findings on the static side, the way that we look at those is, again, the vulnerability type, and then we look at the data or control flow path as the activity works its way through the application. So sub goals, again, we want to standardize vulnerability types. We decided on the MITRE folks for that. We need to match the dynamic and static location. So I need to know this, when I build this application and start to run it, this piece of code is going to get attached to the edge of the web application here, right? So I need to know what code running is touching the attack surface of the application. We also need to know, again, what the parameters coming in are so that we can match the parameter usage inside of the application statically with the parameters that are being passed in by the dynamic scanner. In order to build, so what we build, essentially with this technology is that you point it at source code and it builds a data structure that is essentially the attack surface of the application. Here's every URL that this application will respond to, and every parameter that can potentially change the behavior of the application. And we keep track of, here is the source code responsible for the start of that behavior in the application. So in order to build this data structure, again, you can point it at Git, subversion, you can have a local copy. We basically just need a copy of the source code, preferably all of the source code. And what we do from there is we go in and detect the framework type. So we'll look and say, this looks like an application that is written in Java, and it has the presence of configuration files that seem to indicate that this application is using the Spring framework in order to do its stuff. And right now we've got support for Java with kind of raw JSPs, Spring, and struts. For C#, we've got support for .NET Web Forms and .NET MVC. For Ruby, we've got support for Rails, and we have support, some basic level support for PHP. I think PHP is going to be tricky to support just because, if you look at, like, every PHP framework is doing, well, number one, there's like a million different PHP frameworks. We're not actually executing the code. We have to parse it statically. So we'll see. So for basic PHP applications, our stuff works very similar to the way that we work for, like, JSP applications. We also take in extra information from static testing if available. So like in your Fortify SPRs, for example, they package in some additional information that they get. And we use that if it's available. Again, as I said, we're pretty much static technology agnostic. We don't care what the results are as long as we have them in the data structures that we need. So if that information is not available, we don't need it. And again, from a source code standpoint, we can consume, if you look at a lot of the, like, Checkmarks or Fortify, they package a chunk of the source code from the application inside of their delivery, FPR, XML document, whatever they have. We can operate at a lower level of efficiency if we only have that. We prefer to be able to see all the source code. Unsurprisingly, that provides better results. So a little bit of background about that. And so what we build out of that is a database. And again, this database keeps track or enumerates all of the URLs that the application will respond to. So if I send an HTTP request, I should expect to get a response back if I have this in the URL. Or like if I send this URL and the application is going to do something, it's going to touch some sort of code. And we also keep track of all of the of the parameters and where those parameters enter the application source code as well. And so from that, to do the merging, essentially what we do is say, well, I have a slight correction to my slides. There we go. In addition, I have a slight correction to my slides. You can say I have a dynamic result, and it says we've got a reflected cross-site scripting vulnerability for login.jsp for the username parameter. So that's what we consider to be a unique dynamic result. Then we query the endpoint database and say, what piece of source code does this actually touch? And what's going to come back is, hey, this is a Java Spring application. That request is going to start hitting the application at com.whatever.whatever.login controller.java line 62. And then to match those up, we can go and look through our set of static results and find out, hey, we do have a reflected cross-site scripting, and the entry point of that vulnerability, the source function in the static analysis starts at comment at whatever at login control at Java line 62. If we find a match, we say, I believe this is one vulnerability. We have two pieces of information about as opposed to being two separate pieces of information about different vulnerabilities. Magic. So, any questions about any of that so far? Perfect. So, my question, because I'm never happy, when the security engineer explained, like, hey, here's how this works, and I've got these results, and I said, well, what else can we do with that? And so the first question I posed was, could we, if we have this endpoint database, instead of querying for a specific endpoint, could we also, for example, just do a select star, right? What if we knew all of the URLs in the application? What if we knew all of the parameters that were, potentially going to change the behavior of the application? What could we potentially do with that? And so that's a lot of what we're going to talk about here today. Is if we have that attack surface enumeration, we know these things about the source code. What else could we potentially do with that? We can also go the other way. I won't talk as much about this, but we can do some interesting stuff where if you have only a dynamic scan, but you also have this data structure, you can take a dynamic scan result and map it to a specific line of code. So we've also created like IDE plugins that will let you say, well, I've got a dynamic scan with an app scan or a whitehead or something like that. This cross-site scripting vulnerability, if you want to remediate that, you want to start looking for that at this particular line of code. You may have to make your, put your encoding function or something like a couple steps in the data flow down, just depending on what the right thing to do is. But at the very least, here is a starting point to do that. And also, earlier versions of SonarQube required you to map things to a specific line of code. Now I think the plugins don't require that specific mapping, but in previous versions of SonarQube, this would let us at least say, well, hey, if I've got these dynamic scan results, I can pump those into SonarQube for organizations that are using Sonar to do like their, on the development team side, if they're using that for their metrics and dashboarding and backlog tracking and things like that. So what we're going to talk more or the most about today is what if we could give the dynamic scanner seeding process a head start? So we have all of this attack surface. What if we feed that in? And so that potentially is going to let us find things that scanners aren't able to find, or at least aren't going to find in a reasonable amount of time. For example, if you have an application that has landing pages that link into the application, but that you're not going to find as part of the standard navigation. So if you've got different workflows or something where somebody lands, goes through some sort of workflow and links back in, but you have to know that URL before you get there. When you spider applications, you're not necessarily going to find that stuff because the spidering process isn't going to know, like, hey, I should look for contest contest number 1.jsp to look for. Again, the scanners, there's no reason the scanner would know about that. You're not going to fuzz so exhaustively looking, with the deer buster or something like that to identify things like that. And so that's the case we've seen. Also, hidden directories, similar stuff. These URLs that you're not going to find from spidering. And you can also potentially find backdoor or unused parameters, or parameters that, because of the way your crawl works, those were never identified. But if you had crawled or sent in different values for parameters, you might have identified that stuff as well. Also situations where you have like multi-step workflows where you have to have a certain set of values in step 1 before you can get to step 2. So what we can do is we can take, build that data structure and feed it to the scanner, and that improves the spidering process, given that knowledge of the source code. And the hope is that what that can do is to help you avoid false negatives, or situations where an application has additional vulnerabilities, but your testing didn't identify those. There's a lot of focus is placed on false positives, which I think is totally fair because most commercial tools and open source tools these days find way too many false positives, and that's a huge, from an economic standpoint, that makes it really hard to wade through the results coming out of there. This actually helps with the alternate side of that, which is also a challenge with those false negatives. What are the problems? What are the security problems with this application that we don't know about? And that's something, again, especially as you start to if you're incorporating testing into your CI or CD pipeline, knowing that you're getting a good crawl for these applications, I think, is always something you need to be concerned about. But you need to make sure that when you're doing scans, or if you want to feel good about the fact that you're doing scans, you should probably also be justified in feeling good because you are getting thorough enough scans of the application. Just some quick thoughts on the SBIR stuff, and we'll jump in. In my humble and totally unbiased opinion, I think it was a great use of the program because this is some technology that we looked at and we played around with, but didn't necessarily have a huge enough of a market driver for us to look at independently. And so by providing this funding, and this is not a grant, it's a contract, right? We had specific deliverables that we had to provide through the various stages, but that proved to be the tipping point for us to develop this. Research presented or produced a successful outcome, or at least we think. We found other stuff that we could do with the technology, which is really cool. And this wasn't a requirement. This isn't a requirement of the program, but was something that we did to hopefully drive more commercialization. We released most of this technology open source. All the stuff that we're talking about today is all available open source. And I think that was a cool, from a pay it forward standpoint, or whatever, however you want to look at it. I think that was I think that's a great use of the program to say if we're going to fund this out of public dollars, it makes sense for the public to benefit from that as well. So again, this is not a talk about SBIR. I should also probably say that the DHS, S&T folks, or DHS in general, I'm speaking for myself, not for them. I think we were very successful. I think they think we were successful. But certainly I'm speaking for myself, not for other folks. But again, if you have questions offline, I'd love to talk to you about our experience working with that, because I think that was, again, it's opened up some really interesting opportunities for us, and I think it was a cool use of the program. How do you get, to get these plugins, and again, the ZAP and burp ones I know are available right now. The code exists somewhere for a version for IBM AppScan. I need to track down exactly where that is. We're going to be looking specifically at ZAP here today because ZAP is pretty cool, and it's an OWASP project. But to get the plugin, you can either pull it from the GitHub site, github.com/denimgroup/threadfix, and we've got build instructions for that. And there's also, you can download the plugins from inside of ThreadFix. And so if you've got a running ThreadFix version, you can go in here, and we have a little download tools page. And the way that the build works, it builds all of these little widgets or components with it, and then packages those inside the WAR so that and this is less relevant in this case, but so that you know that the version of the plugin was compiled to work with the version of the server that you pulled it down from. That is available there. Any questions by so far? Boston had questions by now. I'm just saying. Just saying. So the plugin installation instructions, again, this installs just like any other ZAP or any other ZAP plugin. We've also got the plugins available packaged for Burp Suite, and trying to track down where the AppScan one is as well. And so once you've done that install, what are the things that we can do with this? Similarly to how penetration testing is maybe not technically correct for what we're talking about here. To make the title catchy, I had to make it fit into a pattern. But some of the things we can look at is attack surface enumeration, backdoor identification, and a checking of configuration settings. So those are the first three things that we've seen that we can do with this technology. So what do I mean by attack surface enumeration? We talked a bunch about the spidering process. What we want to know is all of the URLs in the application. I want to be able to see all the stuff in the application, and and be able to fuzz all of this stuff. We also want to know all the parameters that will change the application behavior. We're also working right now, and I think this is close to being done. I just don't know where it is. But also looking at other points of contact that you have where you can change the behavior of the application. So right now we've got support for get parameters and post parameters. If you look at other ways that applications change the behavior, the way that you feed data into that, those can be things like HTTP cookies, where you grab a cookie value, make a decision based on that, or just more broadly HTTP headers. So that should be coming to this technology as well. Right now it's supporting get and post parameters, which from a impact standpoint, if you're concerned about missing things from a coverage standpoint, those are probably the more interesting areas to look at. So why is attack surface enumeration even a problem? And I talked a little bit about this before. You have applications that have hidden landing pages. You've got multi-step workflows where the spidering process gets to step 1 but doesn't maybe submit the right stuff to make it all the way to step 2. Checkout processes, things of that nature. There's any number of different workflows that can happen. Again, unknown parameters, things that parameters that you wouldn't see in your crawl because of the way you exercise the application, but that might exist. Also, debugger backdoor parameters, we'll talk about them kind of more specifically on their own. We've also had some success using this to enumerate REST APIs. So if you've got single-page web applications, especially in the case of mobile applications that have, that are calling back into REST APIs, this can be really valuable to be able to know what are all the different REST methods that are exposed, and if they're taking parameters, what are the stuff that they're taking. That's stuff that, again, the web application scanners aren't going to find. If you want to find that stuff, you're typically going to have to wire up your mobile application through a proxy, hopefully getting around any kind of certificate pinning nonsense that the application might have, which is not nonsense if you're using it to protect yourself, but it is nonsense if it's making it hard to test the application. So you can also use this for things like Ruby on Rails and Spring, where they actually know, they understand that from a RESTful standpoint how these APIs get exposed. You can use that in order to dump out all of those REST endpoints. And that gives you, again, information about all of the different stuff that this application should respond to, which can be a real challenge for certain applications where the crawling stuff doesn't do well. Talked about this above. Reduce false negatives from scammers, gives you better coverage for your standard fuzzing, and it lets you know, hey, am I testing all of the application, or are there entire chunks of this application that I don't know about, like weird things that get exposed. Things that the developers might not even know that they're exposing, but that but that we can detect because we're looking again across all the source code, applying a transformation to that source code, and saying, hey, this is where code is going to be actually attached, where it can listen to dynamic traffic. So one thing we have is an endpoint command line, and that is pretty easy. You basically just do Java jar, whatever the jar name is. Like each build changes the jar name slightly, which is annoying, but whatever. And you point it at the path to the source code. And what it does is, again, looks at the source code, detects the language and framework, consumes all, goes through and parses the appropriate classes or other artifacts, and then dumps out the attack surface. And so if we just see what that looks like. That you know what's not readable? Green and black. Just because I think it looks cool doesn't mean that it helps you guys in the least. So there we go. Slightly less horrible. Yeah, it doesn't look cool, but all right. Also true. Endpoint dependencies. There we go. Doesn't like all this stuff from the Git directory. There we go. Okay, so here's what this looks like. This is actually pointed at ThreadFix itself. And so what we see here is we can see that this API will answer to these various endpoints. What you can see here, for example, is that we can pull code. We're pulling markers. We pass in an ID, and that ID parameter we can potentially pass in an app ID. We see these post parameters, or basically post functions and whatnot. And so this shows us essentially every URL in the application that should respond to something. And what we also know, just because of the hybrid analysis mapping is doing framework detection, it knows about REST concepts like path parameters. And so here, for example, we know that we're looking in /organizations/ID. And so what that means is, like, what we would do is pass in an organization ID there. And another area where this is actually helpful to understand the structure of the URL is to give you the ability, especially when you're taking, like, a lot of the dynamic scanners are really bad when they're crawling applications that have a RESTful style of URL creation. You end up over-reporting vulnerabilities, right? Hey, here's like /organizations or /pets/1/whatever /pets/2/whatever, and it says, well, here's 50 cross-site scripting vulnerabilities. It's like, no, your crawl of the application is essentially overcrawled and thinks there are more URLs, because what it doesn't know is that no matter what ID I put in there, that is still going to map back to the same source code getting executed. But because we understand the application framework, we can look at two URLs and say /pets/1 and /pets/2. That actually is going to touch the application code in the same place. Therefore, if you find these cross-site scripting or SQL injection, or if you find multiple vulnerabilities reported at this specific location, that actually maps back to one entry point location in the source code, so you actually have one vulnerability. And so, again, using this data structure, what it lets us do is to potentially collapse down over-reporting of vulnerabilities based on a dynamic scanner, not fully understanding the structure of the application that it's testing. And that's, again, it's a limitation. Some of the scanners do a better job these days than they did in the past, just because the RESTful style URL creation is popular. But all of them don't. So that's another advantage of understanding a little bit about this, is you can apply a filter over the results you get of the dynamic scanners and say, actually this is one vulnerability that got reported 5 times. Let's collapse that down and only look at that one. Any questions about the attack surface? Yeah. We don't right now. What we may be doing in the future from an extension standpoint, like the way that this parsing works is, it's basically doing, kind of lightweight or crappy semantic analysis. And so what we're identifying right now are, here are the points where certain function calls are indicating we are touching code or traffic that comes from the web. What we could also potentially do with that semantic analysis is look for, on the flip side, right now we're looking for source function, but look at the other, the termination on the other side to say, here is a sync function to execute the SQL query or get a connection or whatever. And so what we're looking at is saying, can we use, if we're building this type of a model where we can say, well, here's the web attack surface on this end, can we also look on this side to say, and I know this is calling a database, or I know this is calling out to LDAP or some directory server, exactly, so that we could say, I mean, it's essentially like auto-building a very broad stroke threat model to say, I know I've got these source functions, and so here are the potential inputs. I've got these sync functions, so I'm talking out to interpreters on this end. And so that's some of the stuff that we're looking at doing going forward, is to better, is to say, can we, with the raw mechanics of what we're doing, which is this lightweight semantic analysis, can we look for exit points as well? And given that, that then, again, you pass it over it, and as a pen tester, crafting a kind of crappy threat model before I get started, this lets me know, oh, hey, this is talking to LDAP, and it has, it looks like it's, based on the configuration, it's talking like 3 different databases, right? Or this, this sort of things out to files, whatever else it might be. And you wouldn't necessarily be able to catch that with the type or the quality of the analysis that we're doing, but at the very least, what it can do for you as a pen tester is put that on your list of, hey, we're saving this to file, especially looking at mobile applications, which is another area that we're looking at extending this to say, okay, well, I know that I'm storing things out to 2 different SQLite databases and 3 files. I'm going to go check those to make sure of how the permissions are set and things like that. And we've been able, like not with this technology, but other stuff, to automate some of that in like Android, doing some, kind of lightweight data flow analysis of the like reverse Java stuff. And so that, I think, that's a direction that we're looking to go with this, is to provide not just entry stuff, but also information about exits, because then that lets you know, hey, this is talking to LDAP. Okay, well, let's, like, what do I do when I test applications for LDAP? Or what are my abuse cases for LDAP, for databases, for local file, for pulling in environment variables in a web app, which is weird, but would be something I'd want to think about. So, great question. That is a Boston quality question. Yeah. Uh-huh. Uh-huh. And so it would just, oh yeah, sorry. He's asking, so saying the hybrid analysis mapping lets you map or match static and dynamic. And I think the question was, how's like in ThreadFix, how would it display a static result when the dynamic was obscured? And the answer is like if we don't do a match, we would just say, hey, here's the static that we found, and that stands on its own. If we can do a match, then we would say, hey, here's one vulnerability, and here's the request and response, and here's the code flow from the static. So it's really a situation where as you dump additional information in and it passes through this, if you have 100 static and 100 dynamic, that may have some overlap. In a worst case scenario, you're going to see 200 results. In a best case scenario, where truly they all line up, you're going to see 100 results with like 2 things for each of them. So yeah, good question. Yep. And so, so the question is like, how does this compare to IaaS technology, where you've got something running inside of the thing? Great question. IaaS, as it matures, I think is going to produce better analysis or better insight than this. Where this is potentially more useful and on a case-by-case basis is where you have a already existing. If you've got a whole bunch of static results and a whole bunch of dynamic results, like you can use this technology to clean those up and take action on them. Also, where this is also valuable is to create IaaS support for a new platform is a pretty tremendous investment, right? To say like, oh, I'm going to instrument the JVM so that I can, oh, now I've got to do it for .NET, now I've got to do it for JavaScript, now I've got to do it for Ruby, now I've got to do it for Python, right? There's a huge, entry price to do IaaS on a platform, whereas you can incrementally build support with the data model stuff that we're, the way that our stuff works. I want to say our Spring support is 1,000 or 1,500, maybe 2,000 lines of code, which is not nothing, but it's also not a tremendous investment of engineering. And so, so if you look at saying, well, I've got this new platform out there, you can, and also you can make the model gets better over time as you're exposed to new source code snippets and edge cases and stuff like that. So I love IaaS. I think it's great. Certain people who are IaaS vendors would come and tell you that you're stupid for running a static analysis program or a dynamic analysis program and that you should just use IaaS. I don't necessarily agree with that. And I think, again, like the biggest kind of immediate use for this stuff is if you've got results or if you've got a program that you're rolling out, it doesn't matter. You can use this to make sense of those results, and if you have net new platforms that you need to add support for, the investment is significantly less than it would be to like wait for the IaaS vendors to get around to Python or something like that. It would provide results that have and that's the cool thing about the IaaS stuff is they can show you requests pass through the source code response. From a remediation standpoint, that is magic. And so this allows you to provide that fidelity or that quality of results to the team doing the remediation. Via the use of much more broadly deployed technology. Any other questions? Good. All right. Show you the attack surface speeding demo here. And I think folks are probably running a little short on time. But basically, with that ZAP plugin, we install a little widget in the in the menu, so we can say import from source. I want to import stuff from budget. Go and I've got budget's URL running here. We can go ahead and feed that to dynamic URL. And so what the plugin does is it enumerates this, and what it's going to show us are results that we might not see otherwise. And so if I'm running as an unauthenticated user, I might not think to, or the crawler might not think to look for admin.jsp or some other like harder to guess page description. But by preceding, we already know that that's there. And so we can detect, as in this case, a scenario where that's a page that you shouldn't see unless you've logged in, but that but again, that the application will respond to even if you haven't logged in. In addition, we'll look at this a little bit more in a second here. What we see is we have these parameters called debug. Those are parameters that you would never see during a normal crawl. That's never going to appear in the HTML or the JavaScript, but it is something that will change the behavior of the application. And so as we look here, looking for potential backdoor parameters. A great example of this, I was working on a Cold Fusion application a number of years ago, and they had cut and pasted a snippet of code into every Cold Fusion page where if you passed in a parameter named D, the behavior of the application would be to delete the order of whatever the value of that parameter was. So if you passed in D equals 1,000, the application would delete order number 1,000, right? Like, why? I don't know. It was probably a convenience function for a developer, something that they put in there saying like, hey, I don't want to go through the user interface. If I can just pass this in on this one page, that makes it easy for me. What that resulted in was this behavior that you would never expect from the application, but that if I'm a penetration tester and I see, well, why am I supposed to pass this D parameter in? That's going to cause me to potentially want to fuzz that or going to go, find out in the source code where did this come from, because it's weird that that stuff is there. And so it's hard to identify in an automated way backdoors, because those are typically, like a true backdoor is going to be a business logic flaw in the application, right? Something very particular to the logic of the application. But by understanding more about the attack surface, which you can do by using the model we're creating from the source code, that at least puts you in a situation where you can say, well, why is this parameter here? I didn't know, my dynamic scanner didn't find this stuff was here. Let me go in and investigate further, and then you can make a determination. And so, again, what this can do is tee up for you as a human to look and say, I don't understand what this is. Let me fuzz this, play around with this, potentially go and reference the source code, because I don't know why this is here. And so it's similarly we looking at those debug parameters. You can also look at configuration settings. So you can look at a lot of these MVC frameworks. Everybody's familiar with these auto-binding vulnerabilities and things like Spring, things like Ruby on Rails. You have the ability, depending on the configuration, to potentially set values down the object tree. With a parameter by, if you've got a parameter like user.address1, right? So I can send in a parameter user.address1, and for that user object, it's going to go set the address1 string for that. And there's been a number of problems identified if you don't control how deep you can go. Depending on the way that the object tree is set up, there's potentially references that let you go back up. You can set things that aren't supposed to be there. And so what this lets you do is visually, like you can just go through and identify situations in like Ruby on Rails or in Spring applications where you can just look and see, hey, wait a minute, why am I able to set things, for this particular URL, why am I able to set things where it's like X number of steps down X number of steps down the tree. So you can look for these long parameter names, and we have a couple of examples. Here's a great example right here in ThreadFix. There's apparently a reason for this, I've been told. But you can look for situations like we see, vulnerability.org finding.user.global-role.can manage applications, right? And so if you don't have and you have the ability to control how deep these things can be set through the configuration, through the source code. And so what you can do as a pen tester is identify potential situations like this where where those control settings have not been done properly. And so again, this lets me know, like rather than going through and manually reviewing all that configuration, I can just dump out the results and quickly go through and see, like, hey, that doesn't look exactly right. Let's go in and investigate that more specifically. So you can potentially identify those situations where you are where you don't have good configuration. And so the way that we do that in Spring, for example, we go through and identify all of the controller classes, all the ones that have controller annotations, and then we parse through the annotations on the methods to find out where do those get attached to the web. We also go through and parse all of the model classes and look at how the object tree is stacked up so that we can look for those situations where you may potentially have those nesting. And then we similarly read the configuration to identify which of these properties can actually be set. So this allows you to, in an automated way, take advantage of that type of analysis so that you can basically just dump it out and look for anomalies as opposed to having to manually go and do an audit of all of these things. So, what did we cover? Looked at a couple of different things. Looked for automation stuff, automation things that we could do. What else could we do? I think like what we're also working on right now is adding the concepts of authentication and authorization to these, so that you can identify, like, hey, for a given vulnerability, like if you run a scan and find 1,000 cross-site scripting vulnerabilities, which ones are the most serious ones? Right? Well, for Spring, we can identify here are the endpoints that you have to be authenticated in order to touch. If I'm looking through and adjudicating results, if I've got 1,000 cross-site scripting, 500 of them can be accessed unauthenticated, 500 of them require authentication. I'm probably going to go look at the ones that are exposed unauthenticated first. Right? And so that's, we're adding right now the concepts of authentication and authorization, because that lets us potentially do interesting stuff. Again, result prioritization, also being able to take, well, here's what a spider crawl of the application looked like. Oh, well, that looks like you crawled that with an administrative account or a user account or a shopper account or something like that, because we can line up the URLs that were successfully accessed and look at that compared to, from the model standpoint, like what sort of access we might potentially have. So I think that there's a lot of really interesting stuff that we can do. Look for access. Are we using crypto to your point? Are there crypto functions in use? What I would love to see, and this is something that would be really interesting to fold under like the OWASP testing guide or something like that. Basically taking this idea of what are the ways, like how do we balance the use of source code versus dynamic testing? What are the strengths and weaknesses? And can we make that more programmatic in that in how we can say, if you have access to source code, here is some automation you can apply to that to feed into the dynamic testing, so that you're getting that more comprehensive coverage, but with a minimum or with a less of an investment than you would have to do if you were doing all this testing without actually having access to that source code. So I think there's some pretty cool stuff that can be done with that. And again, we're working on different things for this, but I'd love to hear suggestions from folks who have other ideas on how you could potentially feed between the dynamic and testing, dynamic and static testing being done at the same time. Now I'll open it up for questions. Yes. Yes. And we've got and I can talk about that with you offline. We've got a contributor agreement that basically lets us roll. It says like, hey, we'll release any contributions we'll release under this open source license, but we can also roll it into the commercial stuff that we're doing as well. So I say it's very similar to the way the MySQL project works. It is exactly the way that MySQL project works because I took their release form and marked their name out and wrote ours in. So very, very similar, except not with MySQL. So, great question. Yeah, and that's something where if you have, and we've talked to some folks where they're like, oh, well, we're using XYZ framework, and like, hey, that's not on the roadmap. But again, it's, I think we've got some documentation out there that talks a little bit about like, hey, here's the data structure that you need to build, and you've got some example code and stuff. Yeah, so if there's additional frameworks or something, or if you have examples where it's like, hey, you guys aren't parsing this type of case, again, would love just reach out to me and love to talk more about that. I'm also pretty easy to find. I'm just Dan at Denver. Any other questions?
Have you started gathering any metrics on how good this is at reducing false positives, or how much time it saves in like testing cycles or different engagements or repeat engagements? Yeah, so we've got where we do have some information is more about the match ratio. Like because that was the original point in developing the technology. It's like, hey, for our example applications, what percentage are we able to hit where we're matching a Fortify and an app scan results, and that was like 79 or 80% for our test bed. The challenge is really with the challenge of collecting those metrics and there would be two ways to gather that effectiveness data, either like in a laboratory or in like the real world. And the challenges with collecting that data in the laboratory are getting an acceptable set of testbed applications so that you can say, hey, we found, like, without pre-seeding, we found 100 vulnerabilities. With pre-seeding, we found 110 vulnerabilities. Therefore, you get 10% more coverage from that. And the challenge there is all in creating that testbed. On the flip side of that, I would love to get some better operational metrics on like the type of stuff that we've found. Very scary. Can we, other than anecdotally, can we capture, hey, like these vulnerabilities were found only because we had this stuff? I would love to have it. We just haven't, like our like internal like metrics tracking and gathering is just not at that state right now where we could do that. But I think that it would be very interesting stuff. So at the very least, what I would like to do is get a kind of laboratory test bed so that we can show, you know. Yeah, well, and so that's essentially what we're doing here with the scanner seeding is saying, given source code, we can train the scanner, the dynamic scanner. I haven't found a lot of great feedback scenarios for the dynamic scanner informing the static scanner. There are some interesting things that we've looked at where you could potentially tell, like by looking between commits to say, well, like between commit 1 and commit 2, here's how the attack surface changed. And therefore, if we want to do very focused dynamic testing, like, hey, at the very least, we know we added these 3 new URLs with X number of endpoints, and you know, and even though we're not doing like full taint analysis like you get from like a Fortify or whatever, check marks or whatever, you know, there are some cases where we can identify, hey, this looks like it changed. That would be interesting to, like, especially as you look to integrate this type of stuff in like a CI/CD pipeline where you can say between this commit and this commit, I can run a very focused dynamic scan only on the parts that I know changed. And the danger there is you have false negative danger, like increased false negative danger if you're not doing a full scan. But again, depending on how quickly your cycle times or what your cycle time requirements are for your CI/CD stuff, you know, it may be better to be able to do at least like a kind of a quick wash scan as and then like expect to catch one on a nightly build or on a weekly thing or something like that. That's where we're going to do the full stuff. So I think there's some cool stuff that you can do, like just knowing the attack surface and being able to watch that change over time. I think allows for some really interesting stuff, which is why we release the technology open source, so that other people can do cool stuff that we don't have time for or didn't think of yet. So.
Dan, like with WebGoat, do you know of any online sources of good known vulnerability applications that you can test without getting in trouble?
Yeah, OWASP has their broken web OWASP BWA or something like that. They've got like a VM that has a bunch of applications on it that is a good source. I think it is if you look at the value of those test beds, I think that's a great source for aspiring testers to have stuff to work with. I think it is a mediocre to slightly crappy tool metric gathering test bed because you have things like WebGoat where, like the way that WebGoat makes their URLs like doesn't work with our stuff because it's like you pass in a parameter and it's like it runs and attaches to something. It's like a kind of a goofy thing, you know, which you see occasionally in the real world, but not really that frequently. You know, and so. You know, again, if you're looking at something like BWA, I saw something else recently that if I can track that down, I'll email the folks here. But again, and like the NIST folks have their test bed, the Juliet test bed, which I think was from NIST or might have been from NSA. So the federal folks have put together a couple of these things as well. The real challenge is that there aren't a lot of great. It's not like it's not like any of the top 5 banks are like, hey, we end of life this application. You know, it's no longer running. For the betterment of the world, we're going to release the source code so that people can see here's what a real world line of business application that with like 500,000 lines of code look like. There's not a lot of organizations that are being like, hey, there's no harm. Exactly. Come hack me, or here's this code, or again, there's and that's the unfortunate thing because. That would be tremendously valuable, but I think there's nobody. It's not there yet. It's not valuable enough. The people that have that, there's way more risk or way more downside than there is upside to releasing stuff. Even end of life applications where it's like, hey, there's still IP involved there and all that stuff. Yeah, and you can see there's old versions of WordPress and stuff, and so that's useful and interesting. But again, the open source stuff tends to be more framework oriented, where I think most organizations have their greatest concerns around like line of business type stuff, and so it's a different type of app, and so it's not really necessarily giving you it's not testing exactly the thing that you really want to know the most about. So.
Well, it looks like we're at the 1 o'clock hour. Unless there's someone ahead, we can do one more question, but anybody? Nope. Okay.
All right. Thank you all very much.
Thank you very much.
For a while.